So in the last lesson, we talked about polynomial functions. And so we went through some of the characteristics of polynomial functions. We went through looking at some of the graphs of those functions, and went through looking at, with those graphs, some of the zeros and where it was increasing and decreasing in the end behavior. And we started analyzing some of those graphs, but today, more specifically, we are going to go through and just analyze the graphs of those polynomial functions. So we're going to go ahead and we're going to graph some of those things that are a higher degree than we have before. We're going to look at how to go about finding other things as well. So we're not going to get super in-depth. We're just going to find some max and min points and some major things that you need to be able to find. Let's go ahead and take a look at this first function, x to the fourth plus x cubed minus 4x squared minus 4x. Making a table of values. So simply, there is a way to graph this without making a table of values. We're not going to worry about that. We're just going to start by making a table of values. So what you want to do is you kind of want to go every half step, is what I've done here. And that'll kind of give us a general idea of what these points are and what they should be. So I'm going to go ahead and copy in. What you would do is just plug this into your calculator. You have negative 2.5 to the fourth plus negative 2.5 cubed minus 4 times negative 2.5 squared minus 4 times negative 2.5. I'm going to go ahead and give you these values, so we're not going to take the time to sit here and figure it out. And so you can fill in these values. So the first one is 8.4, and then 0, and then negative 1.3, then it comes back up to 0, then we have 0.9, and then it goes back down to 0, and then negative 2.8, negative 6.0, negative 6.6, and then it goes back up to 0. So what we're going to find out by the end of this chapter is that the number up here, the degree, tells you how many roots you should have. Now again, some of those might be imaginary roots, because we have discovered that some of them are fake. Imaginary, not fake. So we notice here we have 4 zeros, so those are actually the answers, but we're not worried about those, we're just worried about the graph of it. So I'm going to go ahead and say, so we have a negative 2.5, which is about here, and we'd be up at 8.4. So then we're up here somewhere. So we're about there is where we start. And then at negative 2, we go to 0. Then at negative 1.5, we go down to negative 1.3. So we're about here. Then at negative 1, we go back up to 0. At negative 0.5, we're almost to 1. Then we go back down to 0. At 0.5, we are all the way down at negative 2.8, so almost to negative 3. At 1, we're all the way down at negative 6. Then we go down to negative 6.6. And then at 2, we're all the way back up to 0. So right now it looks like a whole bunch of dots. What we want to do is follow those in the order that we did them. So we'll come down, we'll curve, we'll go back up, we're going to curve back down, continue to curve back down, and then shoot straight back up, like this. And notice we had a quartic, degree 4, and it has that W shape. It's even, they both go in the same direction, it's positive, so they both move upwards. So here the end behavior for this, as x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x also approaches, it also approaches infinity. So as x goes off into both directions, it should be going upwards. And that's all there's to it. So when we want to graph by making a table, you just plug in your calculator repeatedly, all those values, get what they are, and you plot them. That's no different than what we've done before. So let's go ahead and take a look at the next one. Now I know you all know that I'm going to give you the answers because this is a video and these are examples and that's what I do. However, I would like you to take a second, pause the video, and find those values yourself. See if you can go through on the graphing calculator, pause the video, and see if you can get those values yourself. And then when you come back, I'll, of course, be giving you those values. But that way you can just kind of see, that you're able to do it on your own, at least finding the first few, so that you know you have the capabilities of doing that. And if you don't, then that's somewhere you need to ask questions of how to plug it into a calculator or whatever. For these values, notice how high they go. I'm not worried about you graphing 45.9 and 18. If it's way up there, I'm not worried about it. But we do get to reasonable numbers at negative 1.5. So at negative 1.5, I can go up to 4.7. So that's our first value. And notice we're coming down this direction because we started up super high. Then at negative 1, we go to 0. At negative 0.5, we're at negative 0.5. Then we go back up to 0. Then at 0.5, we're at 0.2, so we're just above. And then we go back down to 0, so it's just a little curve there. And then at 1.5, we're almost to 1. And then at 2.0, we're all the way up at 6. So as we're looking at this, when this comes down, notice it still kind of has that W shape. However, somewhere in there it has to flatten out a little bit because one of those is a double root. Because we only have 3 roots and eventually we'll get to 4. So if you remember we had the vertex, we'll notice here how the vertex is at this, it's a double root. So that's where we're getting that double root in there. And that's why we only had 3 of them instead of 4. So again, as x approaches negative infinity, f of x is approaching infinity. As x is approaching positive infinity, f of x is approaching positive infinity. They both go the same direction, they're both going up because it's a positive, even graph. So now we're going to take a look at what we call the location principle. So if we have some function, and it represents a polynomial that we've been looking at, what we can say, there's 2 numbers such that when you take the values of those functions, one is less than 0 and one is above 0, then the function has at least one real 0 between a and b. So if your y values change sign from negative to positive or from positive to negative, what that means is, even though we didn't actually find it, there is a 0 between those values. So again, let's look at another graph. This time it's a cubic graph. And I am going to go ahead and give you the values for this one as well. In fact, this one might even already be on your notes there. Let's see. So I only have them here in the book from negative 2. So we'll just start here at negative 2 is negative 32, negative 7, 2, 1, negative 4, negative 7. And then I'm actually going to change that and continue on down to 4 and 5. So then if I have 4 and 5, 4 gives us the value of negative 2, and 5 gives us 17, because there's another sign change in there. So you can ignore those first ones, because it just goes really high and it's not really worth our time. So what we're looking for, so this is determining consecutive integer values of x between which each real 0 of the function occurs. So we're looking for where does it change from positive to negative or negative to positive. So notice it changes here. So I'm just going to label that as 0, because there's some 0 in between there that's occurring. Then here again, in between these two, there's a 0. And then over here in between 4 and 5, there's a 0. So we don't know the actual value of the x's, but we know they're somewhere between -1 and 0. So I'm going to go ahead and plot these points because we want to draw the graph. Notice this is an odd function, so as x approaches -infinity, f of x should be approaching something, and as x approaches positive infinity, f of x should be approaching something else. If it's odd, they go opposite directions, remember. Since it's positive, when we have -infinity, it goes to -infinity. When we go to positive infinity, it goes to positive infinity. So they're going different directions this time. So -1 gives us -7. 0 gives us 2. 1 gives us 1. 2 gives us -4. 3 gives us -7. 4 goes to -2. And then 5, I'm not actually going to graph it. It's all the way up here, but we know it crosses that axis again. So we're coming up from down here, we go over, cross back down, and then we continue up. So it should look something like this. That is the general shape of the cubic function, or cubic graph. So we have our 3 zeros. Again, they're located in between -1 and 0, in between 1 and 2, and in between 4 and 5. So those are the 3 locations of those zeros. The second major thing we want to talk about here is what we call relative maxima and relative minima. And that's really talking about maxes and mins. So we're looking for maximum values and minimum values, which are going to be the tops and bottoms of all of those curves and those humps that we've been getting on the graph. We're looking for where are the tops and where are the bottoms of those humps and those curves. So relative maxima is a point in the graph of function where no other nearby points have a greater y value. So it's the biggest between a couple of values. And then the minima is going to be a minimum. It's going to be the lowest y value between certain points. So they want us to estimate the x-coordinates in which the relative maxima and the relative minima occur. So what we want to do, we want to look and we want to do a table of values, which I think I have handy here. Yes. So let's go ahead and do this table of values. Now on your paper, I give you the graph. Lost my marker. I give you the graph. So we're actually going to go ahead and graph some of these. So the table of values you already have. So I'm going to copy them down so I can talk about them with you guys. So we have -5, -28, -4, -3, -3, 6, -2, 5, -1, 0, 0, -3, 1, 2, and then it goes up and forever. So what we're looking for is where, or in between which values, or around where are we going to find maxes and mins. So notice, we're coming up from the negatives, we go up, we reach 6, and then we start coming back down again. So right here is going to be a max. Then we go down, we go down, we go down, we get to -3, and then we come back up again. So here is going to be a minimum. So if I were to sketch these values, so I'm not going to go all the way down to -28. When we get -4, -3, so we have a point here. Then we go to -3, 6, so I'm all the way up here. Then we have -2, 5, so we come down 1. -1, 0, so we're continuing to come down. Then we go to 0, -3. Then we come back up to 1, 2, and then we continue off forever. So we come up, we go up, we go up, we go up, we start to come back down again, and then we go back up again. With our zeros, so here's a max, here's a min, here's a 0, here's a 0, and here's a 0. So those are the things we've talked about. We talked about where to find our zeros, which are anywhere it crosses the x-axis, and anywhere on the table of values where it changes from positive to negative. And then the maxes and mins are anywhere where it changes direction. So if it's going up and then it starts coming back down again, that's a min. If it starts down and it goes back up again, that's going to be a max. Or excuse me, a min. I reverse this. Your homework is numbers 11 through 18 on page 343. So you will need some graph paper and things because there are going to be, these are graphing. You're analyzing the graphs, so you're going to need to graph them. So start by finding all the tables of values, because that's the easiest way to do this. For me to tell you to do this is to find all the tables of values, just plot the points and see what you notice.